Hello everybody. Today we're finding the correlation coefficient of a data set using a Sharp calculator. If we are presented with a data set like this, the first thing we need to do is to identify the independent and the dependent variable. In this case, the X column is the independent variable and the Y column is the dependent variable. We'll be entering these as pairs into our calculator. So when we're doing any statistical calculation on our calculator, the first thing we have to do is put into statistics mode. And to do that, we press the mode key. We do that and the screen appears and we press 1 for statistics. Once we've done that, this screen appears. Because we are doing a linear regression, we press 1. Line stands for linear regression, so we press 1. This screen appears. Now we're nearly ready to start entering our data, but before that we have to make sure that the residual memory is cleared. We could have done this first. It doesn't really matter at what stage, but you have to do it before you enter data. Remember, if we don't do this, any statistical data that was previously entered will be lurking around in your calculator and you'll be adding your data onto pre-existing data, which will give you a totally wrong answer. So to clear the memory, locate C8, standing for Clear All. It's above the Mode button. It's yellow, so that means we have to press second function and then the mode key. That clears all. Now we're ready to start entering our data. So the process is we enter independent variable first, store button, the dependent variable, and then the M+ key. Okay, so in this case, the first row, we would enter 10, press the store button, and when we do that, notice there's a comma appears after the 10. That's there to separate the two data points. Then we press 52, then we press the M+ key. Once we've done that, this screen appears, which says dataset equals 1. That's telling us that we've entered the first row of data. Now, I might add here, it's important to be aware of that, because if this comes up with a number other than 1, that's telling us that you haven't cleared the memory of your calculator, and so you need to go back and start going. Go second function, clear all, start again. Now we're ready to do the second row. So you'd go 20, store, 66, M+. Now at this point, why don't you pause the video and go through and enter the other sets of data, and then start it up again when you've done that. There are 8 rows here, so you should end up with dataset equals 8. Now, okay, so we're ready to call up the correlation coefficient. Now to do that, I'm going to zoom in on the keys. Now, so we have, if you look over here at the divide by button, above it there is a little r, lowercase r, and it's green. R is the pronumeral that represents the correlation coefficient. It's green, so that means we have to press the alpha key, which is below the second function key. So you press alpha, divide by, then you press equals. Okay, when you do that, your correlation coefficient will appear. In this case it was 0.9812, etc. We could round that off, say to 2 decimal places, which would be 0.98. That's your correlation coefficient. Okay, so what does the correlation coefficient tell us about our data set? Okay, if we plotted this onto a graph, which way would the data be trending? Would it be trending increasing from left to right or decreasing from left to right? Would the points go close to forming a straight line, or would they be spread all over the place? These are the things that correlation coefficient tell us. I've actually entered this into GeoGebra and also drawn a line of best fit so you can actually see what's happening with the data. Here it is here. Notice that the points are very close to the line of best fit. So that also fits with the fact that the correlation coefficient of 0.98 is very close to 1, which is a perfect correlation. Perfect positive correlation, in fact. So there you go. That's the correlation coefficient for that set of data. Now I have done a second set of data that I'll get you to enter into your calculators and work out the correlation coefficient. Here it is. Now remember, before you go entering data into calculation, you have to clear the memory. So second function, clear all. Then you're ready to start entering your data. So once again, in this case, the independent variable is x, dependent variable is y. So you'd go 15 store 107 m plus. Next row, 24 store 78 m plus, and so on. So once again, why don't you pause the video, go through and enter the remaining sets of data. There's 12 lines here, so you should have data set equals 12 at the end. And when you've done that, start the video up again and we'll check our answer. Okay, so how did you go? I've done this on my calculator and my answer was R equals negative 0.827, so etc. If I rounded that off to 2 decimal places, it'd be negative 0.83. Okay. Now, so negative 0.83, what's that telling us? It's telling us it's going to be decreasing from left to right, isn't it? And it's the correlation of this is not as strong as the first example. It's still moderately strong, but not as strong. So once again, I've plotted that onto GeoGebra, and you can see the trend here. It's decreasing from left to right, and the points are spread out more so than the first example. GeoGebra allows us to do a line of best fit, and so that you can see how the points are spread about the line of best fit. Okay, so that's basically how we calculate the correlation coefficient using a Sharp calculator.